This is optimization problems, and here in business calculus, the business applications and medical applications are very few in this. So we'll just do a few problems. This is covered in a lot more depth in Calc 1. Let's take a look at our first problem. It's really nothing new in here. Find the length and width of a rectangle that has a given perimeter and maximum area. Okay, so we've got a rectangle. Here's our length and here's our width. And find length and width as a given perimeter and maximum area. So we're talking about area and perimeter. Area, actually we just label that as A. Excuse me. Area is equal to length times width. And perimeter is equal to 2L plus 2W. Perimeter is just adding up all the sides. This is L, so that's 2L. This is W, and this is W, so that's 2W. And they're telling us that the perimeter is 16. So they're giving us that. And they say maximum area. So they want us to maximize the area. That's our goal. Well, our area is length times width. Now, the problem with this formula is we have two variables on the right side. You can only have one variable. Well, if I come over to this formula on the right for a perimeter, we could solve this for L. So I'm going to take the 2W over to the left side. So I got 16 minus 2W is equal to 2L. Divide everything by 2. And we get 8 minus W is equal to L. So we can replace the L over here with 8 minus W. And let me go ahead and multiply that through. W times 8 is 8W. W times negative W is negative W squared. Now everything's in terms of one variable. So we know how to find the maximum. Find our first derivative, find our critical values, build our intervals, and find out increasing, decreasing, so forth. So let's just do that. So take the derivative of A with respect to W. Derivative of 8W is 8 minus, that becomes 2W. Set that equal to 0. So we've got 8 minus 2W is equal to 0. And we want to solve for W. So I take negative 2W to the right side. It becomes a positive 2W. Divide both sides by 2. And we get W is equal to 4. And that's infinity there. Here's negative infinity. Remember, we want to pick test cases. I want to pick a W between negative infinity and 4, like 1. Now, I didn't pick 0, because 0 probably would work, but it doesn't make any sense in terms of this problem. Because if you had a distance of 0, then it wouldn't be a rectangle, it would be a line. And I'll pick something over here, and I'll pick 5. Now we want to plug those into our derivative, this right here, and see what the sign is. So plug into the derivative. So we're going to have 8 minus 2 times 1, and we'll have 8 minus 2 times 5. 2 times 1 is 2, 8 minus 2 is positive, so this is increasing. 2 times 5 is 10, 8 minus 10 is negative, so this is decreasing. So it's increasing and changes to decreasing. So this is indeed a max. Now we're just verifying that. So our max occurs at W is equal to 4. Well, we need to know what L is. Up here it says L is equal to 8 minus W. So L is equal to 8 minus W. And we just said W is 4. So L is going to equal to 4. Their question is find the length and width, and that's what we just did. W is equal to 4 and L is equal to 4. So let me save this. There we go. And bring up a new tablet. There we go. Let's look at our second problem. It says find the length and width of a rectangle has a given area and minimum perimeter. So we're talking about a rectangle again. This is L and this is W. And we're talking about area and perimeter again. So let's refresh our memory. Area is length times width. And perimeter is 2L plus 2W. And they want us to minimize the perimeter. And they say area is 81 square feet. So they're giving us A. Okay, our goal is to minimize the perimeter. So our perimeter is P is equal to 2L plus 2W. Problem with this is we got two variables on the right side. We can either just have all W's or all L's. But our area formula here, I could solve this for one of the variables. Doesn't matter which one. I'll solve it for L. So I divide both sides by W. And we get L is equal to 81 over W. So I'll plug that in now. So I got 2 times 81 over W plus 2W, which gives us 162 over W plus 2W. And I want to put it in right form, take the derivative. So this is W to the first power. I'll take it up to the top, and it becomes W to the negative 1 power plus 2W. Okay, so now we can take our derivative. We'll take derivative of P with respect to W. This one, take your power, put it out in front. So I got 162 times negative 1. And then lower your power by 1. And then 2W just becomes 2. So we got a negative 162, and I'll take the W to the negative 2 downstairs, so it becomes W to the positive 2. And I'll put the 2 over 1, because we're going to want to combine together these into a single fraction. Our common denominator would be W squared. So I got negative 162 over W squared plus 2W squared over W squared. Multiply the top and bottom by W squared, which would give us 2W squared minus 162 over W squared. Well, let's find our critical values now. I'm going to set the top part equal to 0, so 2W squared minus 162 equal to 0, and I'll set the denominator equal to 0. Now for the denominator, W squared is equal to 0. Remember, if you have a power, and you got 0 on that side, you can just drop the power. You get W is equal to 0. Now, W is equal to 0 does not make any sense, so we can even exclude that one, not even worry about it. W is equal to 0 means the width is 0, which means it's not a rectangle, it's a line. Well, let's solve this one. I'm going to take the negative 162 over to the right side, and it becomes a positive 162. Divide both sides by 2, and we get W squared is equal to 81. Square root property. We'll drop our squared, and we'll put a plus or minus square root around the other side. Now 81 is 9 times 9, so square root of 81 gives us 9. So we got W is equal to negative 9, and W is equal to positive 9. Now again, keep in mind what we're dealing with. We're dealing with distance, width. Negative distance does not make any sense, so I'm going to cross that one out. So the only possibility we have is w is equal to 9. Well, let's build some intervals and see what happens. Put w is equal to 9 in the middle. Here's infinity. Here's negative infinity. We want to pick test cases. I want to pick test cases that make sense. So I'll pick w is equal to 1. It's up between negative infinity and 9, but I don't want to choose a negative. Not that it really matters, but just to keep things making sense. And then a value between 9 and infinity, like 10. And then we want to plug that into our first derivative, which is 2w squared minus 162 over w squared. Okay, so if I put 1 in here, the bottom is w squared. It's always positive, so we don't need to worry about it. Same over here. W squared is positive. We don't need to worry about the denominator. Because all we care about is the sign. So put 1 in for w. So we've got 2 times 1 squared minus 162. 1 squared is 1, times 2 is 2, minus 162 is negative. Negative divided by positive is negative, so this is decreasing. If I put 10 in here, 10 squared is 100, times 2 is 200, minus 162 is positive. Positive divided by positive is positive, so this is increasing. So this is indeed a min, which is what they were asking for. They were asking us to minimize the perimeter, which means we have a min at w is equal to 9, and we just need to find out what our y value is. Y, L. Up here, L is equal to 81 over w. So I come down here. L is equal to 81 over w. And we just said w was 9. So 81 divided by 9 gives us 9. So width is 9 and length is 9. And those would be our answers. So we save that. You can make some an interesting deduction from the first two examples we've worked here about what gives you extreme values when you're talking about a rectangle. Yeah, it's when it's a square. Okay, let's look at this one. It says a rectangular pasture borders a river. Okay, here's our river. Rectangular pasture. Looks like that. If we wish to put cattle in this area and don't need a fence along a river, and we want the area to be 100,000 square meters, what dimensions will minimize the amount of fencing? Okay. I'll make this X and make this X and make this Y. Doesn't matter which you put which. They can't be the same, X and Y. They could be, but not for our setup, because it's a rectangle. So you assume this side is the same as that side, but this side's unknown. And we're talking about area, and we're talking about the fencing. Well, the area of a rectangle is this times this, like length times width. And our fencing, I'm going to put, I'll put F eventually, but our fencing, that's going to be X plus Y plus X. So X plus Y, which gives us 2X plus Y. Okay, and it says we want the area to be 100,000 square meters. So they're giving us area is 100,000. And what dimensions will minimize the amount of fencing? So we want to minimize the fencing. And I'll label as F. So we got F is equal to 2X plus Y. And again, how we get mins and maxes, we take derivative. Problem with this formula is we got both X's and Y's on the right side. We can only have one variable. Well, again, easy enough. I can take this one and I can solve for Y. So I divide both sides by X. So we got 100,000 over x is equal to y. And this becomes 2x plus 100,000 over x. And now after we've done that, we can take the derivative of this. So we need to put it in right form. I'm going to take that x the first, move it up on top, and we get 100,000 x to negative 1. Okay, so we'll take the derivative of our fencing with respect to x. Derivative of 2x is 2. This one I'll take the power, put it out in front. So we got negative 100,000. And we lower our power by 1. So it becomes negative 2. Put the 2 over 1. We're going to eventually merge these into a single fraction. Minus 100,000. And I'll put the x to negative 2 downstairs to become a x to the positive 2. Okay. Well, we want to get a common denominator, so I'll multiply the top and bottom of the first fraction by x squared. So we've got 2x squared over x squared minus 100,000 over x squared. So that gives us 2x squared minus 100,000 over x squared. Okay. That's our derivative. So now to find the critical values, we set the top part equal to 0 and the bottom part equal to 0. So I got 2x squared minus 100,000 equal to 0. And x squared is equal to 0. Now, x squared is equal to 0. Again, we can drop the power, since we just have the entire side to power equal 0. But x equals 0 doesn't make any sense, because x is a distance, and if we wouldn't have a rectangle if that was 0. So over here, I'll take the 100,000 to the right side. So we got 2x squared is equal to 100,000. Divide both sides by 2. And we get x squared is equal to 50,000. Now, square root property from college algebra. We'll drop our squared, and we'll put a plus or minus square root around the other side. Now again, this is distance, so negative doesn't make any sense. So we're only going to keep the positive version. And 50,000 is like 5 times 100 times 100. So we can bring a, remember square roots are looking for a pair of something. So we can bring a pair of hundreds out as a single hundred. And we get x is equal to 100 square root of 5. Well, let's build our intervals here. There we go. And we want to pick test cases. In order to pick test cases, we actually have to know what a 100 square root of 5 is. So 100, then the square root of 5, enter. 223.6. So 223.6. Okay, so 1 would be a good one to pick. Over here, 240. Okay, and we want to plug this into our derivative, which was this right up here. So I got 2x squared minus 100,000 over x squared. Okay, now remember, all we're caring about is a sign. So the bottom part is x squared, so it's automatically going to be positive. So we don't need to worry about that on either one of these. Top, though, we'll plug number in. So we'll plug our test case in. So 2 times 1 squared minus 100,000. Well, 1 squared is 1, times 2 is 2, minus 100,000 is negative. Negative divided by positive is negative. So that's decreasing. And if I put in 240 might have been too small. 300 might have been easier to think of. Let me choose 300. Okay, so we got 2 times 300 squared minus 100,000. Well, this is 90,000 times 2 is 180,000 minus 100,000 is positive. Divided by positive is positive, so it's increasing. So it is indeed a min, which is what we were trying to do that. We're trying to minimize the fencing. Okay. So min at x equals 100 square root of 5. Let's see what our y is. Somewhere up here we have some kind of formula that probably ties, there it is. This one right here. Y is equal to 100,000 over x. So y is equal to 100,000 over x. Actually, let me write that out. Sorry. So we got 100,000 over 100 square root of 5. That 0 cancels that 0, that one with that one, and we're left with 1,000 over square root of 5. Can't have a square root of 5 downstairs, so I'll multiply top and bottom by the square root of 5. So that gives us 1,000 square root of 5 over 5. And 5 goes into 1,000, so this becomes 200 square root of 5. So x is equal to 100 square root of 5, and y is equal to 200 square root of 5. I know those are kind of bizarre numbers, but since I made up the numbers, it's not surprising it doesn't come out really nice, like 100 and 300 type of deal. Yeah, let me save that. And bring up another tablet. There we go. And let's look at our last problem. And let me grab a drink. Okay. A normal window has a semicircle on top of a rectangular window. Find the dimensions of a normal window of maximum area if the total perimeter is 200 feet. Okay, so we got a rectangle here. And on top of the rectangle we have a half circle. Excuse me. Say this distance is x. Then this distance would be, let's say, y. And our circle up here, or half circle I should say, here's our center, and going out this distance here, this will be x over 2. Try it again. X over 2. Because all the way across is x, so this is half of x. Okay, so the two things we're working with is area and perimeter. So area is going to equal to the area of the rectangle plus the area of the half circle. So I'll just label that as A. Area of the rectangle, that'd be x times y. Take this side times this side. Now area of the half circle. If we got a circle, our area is pi r squared. If we got half a circle, then our area is 1/2 pi r squared. We got half a circle, don't we? Okay, so this would be plus 1/2 pi r squared. Well, r in this case is x over 2. So we'd have x over 2 squared. Which gives us xy plus, when I square that, that gives me x squared over 4. So 1/2 times 1/4 gives us 1/8 pi x squared. Okay, let's look at our perimeter. Now, perimeter is the distance around. Now, I'm assuming the perimeter doesn't include this piece right here that separates the rectangular region from the half circle. It'd be a different setup if we included that, but the distance around would be this distance, y plus x plus y. So that'd be x plus 2y. So that'd be going from here and going around this part. Then we got our half circle. And the perimeter of a half circle is called a circumference. And our circumference of a circle is 2 pi r. And for half a circle, it'd be half of that. So it'd be half of 2 pi r. So we'd have just pi r. So this would be plus pi r, but remember what r is. R is equal to the distance from the center here to the outer edge, which was x over 2. So that'd be x over 2. So P is equal to x plus 2y plus pi over 2x. Okay, what else do they give us? Total perimeter is 20 feet. So they're giving us P. It's 20. So we got x plus 2y plus pi over 2x. And then what they're wanting is to find dimensions of a normal window of maximum area. So they want us to maximize the area. So maximize the area. Well, area is equal to xy plus 1/8 pi x squared. Now, the problem with this is we have two different variables on the right side. Well, I can get rid of the y. Taking this formula here, I'm going to solve for y. Well, first thing I'm going to do is get rid of the fraction, so I'll multiply everything by 2. 2 times 20 gives us 40. 2 times x gives us 2x. 2 times 2y gives us 4y. And 2 times this gives us pi x. Now, I want to solve for y, so I'm going to take the 2x and the pi x over the left side. So I got 40 minus 2x minus pi x is equal to 4y. And then divide everything by 4. 40 divided by 4 is 10 minus 2/4 x minus pi 4 x equals y. Which means 10 minus 1/2 x minus pi over 4x is equal to y. And now we can replace our y in this other equation with this right here. So this becomes a is equal to x times 10 minus 1/2 x minus pi over 4x and then plus 1/8 pi x squared. Looks nastier, but actually everything's in terms of x's now on the right side. There's no y's left, so we only got one variable to work with. Take x times 10, that gives us 10x. X times negative 1/2 x gives us negative 1/2 x squared. X times negative pi over 4x gives us negative pi over 4 x squared plus pi over 8 x squared. Now these I could merge together, but let me double check my work here. 10x minus 1/2 x squared minus pi over 4 x squared plus 1/2. Okay. I can get a common denominator on those last two. So we've got a is equal to 10x minus 1/2 x squared. And I'll multiply top and bottom of this fraction by 2. So we've got minus 2 pi over 8 x squared plus pi over 8 x squared. So we got a is equal to 10x minus 1/2 x squared. Now, these are both x squared, and we combine what's out in front of them. I got negative 2 pi over 8 plus 1 pi over 8. That gives us negative pi over 8 x squared. Well, now we're ready to take our derivative. So we'll take our derivative of a with respect to x. 10x becomes 10. Here I take 2 out in front. 2 times 1/2 drops away, so we got minus x. Here I take 2, put it out in front, and we get 2 pi over 8, and that becomes x. Equals 10 minus x minus pi over 4x. And that's our derivative. Well, now we're ready to set that equal to 0 and find our critical values. So I got 10 minus x minus pi over 4x equals 0. Now I'm going to get rid of the fraction by multiplying everything by 4. 10 times 4 is 40. 10 times, or negative x times 4 is negative 4x. And this times 4 gives us negative pi x. And then 4 times 0 is 0. I want to get everything with an x on one side. So I'll take the negative 4x to the right side, becomes a positive 4x. Take negative pi x to the right side and becomes a positive pi x. I'll try and get x by itself, so I'll factor an x out, and that gives us 4 plus pi. And then I'll divide both sides by what's behind our x, which is 4 plus pi. So we got 40 over 4 plus pi. Okay, now the question is, we're wanting to maximize the area, and so we need to actually see if this is a maximum value or a minimum value. Could be there's no answer to this. Let me grab a drink first. Okay, so I'm going to build intervals. Sorry for the ice crunching, but I was just dying. Let me see what that's equal to decimal-wise. To put this in my calculator, actually let me show it on this calculator. I have to do 40 divided by, and put beginning parentheses around the bottom, and then 4 plus pi. And then close parentheses in there. So we got like 5.6. Okay, so I'm going to choose x equals 1, and I'll choose x is equal to 10. Because this is roughly 5.6. Okay, now I want to plug those in my derivative, which is right here. So I got 10 minus 1 minus pi over 4 times 1. That's 9 minus pi over 4, and I'll just go do that on my calculator I got here on my desk. So 9 minus pi over 4. We get 8.2. So it's positive, so it's increasing. If we put the 10 in, we'll have 10 minus pi over 4 times 10. 10 minus 10 is 0. That drops away. Negative pi over 4 times 10, I don't know what it is, but it's negative, so it's decreasing. So this is indeed a max. Okay, so we got a max at x is equal to 40 over 4 plus pi. Question is what y is. So let me see if I can find a formula to help me find y. Y is equal to this, 10 minus 1/2 x. So y is equal to 10 minus 1/2 x. 10 minus 1/2 x minus pi over 4x. Minus pi over 4x. Okay, so we got 10 minus 1/2 times x, which is 40 over 4 plus pi, minus pi over 4 times 40 over 4 plus pi. Well, 2 and 40, that 2 divided by 2 is 1, 40 divided by 2 is 20. And then over here, 4 and 40, 4 divided by 4 is 1, 40 divided by 4 is 10. So we're left with 10 minus 20 over 4 plus pi minus 10 pi over 4 plus pi. Okay, so we got this one right here. So now we'll do y. So these both got 4 plus pi as the denominator, so I'll merge them together. So I got 10, and since they both have a minus, I could actually leave the minus out in front. And we'd have 20 plus 10 pi over 4 plus pi. Now to get a common denominator, about out of room, I was going to skip steps, but let me, I'll put the 10 over 1 minus 20 plus 10 pi over 4 plus pi. Multiply this first fraction, multiply top and bottom by 4 plus pi. And up here, 10 times 4 is 40, 10 times pi is 10 pi, minus 20 plus 10 pi over 4 plus pi. Now we want to merge those into a single fraction. And remember, if you have a negative out in front of your fraction, it flips the sign of everything inside. So it's or flip sign of everything up on top. Sorry, I'll wake up here eventually. So we got 40 plus 10 pi minus 20 minus 10 pi over 4 plus pi. Okay, so 10 pi minus 10 pi drops away. 40 minus 20 is 20. So we've got 20 over 4 plus pi. And those will be our values for that. Now I could find the circumference in this if I wanted to. We said circumference is pi r, and r is x over 2. But since I'm about out of room, I won't do that. Now, assuming I didn't make any math error, then those would be our answers. I say assuming because I already created this video one time, and I had where the squared was here, I forgot to put the squared here. It is so easy to make a mistake like that. I would sit here, if I was doing this in real life, as in a class, I'd sit here after I'd done this before I turned it in, and I'd double check all my work and triple check it. But since I don't want to make this video longer than it is and have you just sit there for 10 minutes while I'm silently going through it, we'll assume this is good. So let me save it. And I'm sure I'll hear from somebody someday if they just do see I added or subtracted numbers wrong. So, there's a movie by Jack Nicholson where he's wondering, is this as good as it's going to get? Oh, that's as good as it's going to get with this problem. Let me do that. There we go.